I'm Ray, and today I'm going to be explaining to you a very important point. So, you see, if you are hypothetically on a train and you got bored, so you start bouncing a ball. So, the ball goes up and down. So, what you visualize is a ball going up and down and up and down. So, that is what you visualize. So imagine there is a train station and there's a seat and there's a person, an old grandma, sitting on the seat. So what this old grandma will perceive through the window, because the train is moving, she will perceive the ball here, but it will not bounce here because the train is moving through her eyes, so it will instead go here and form a sort of triangular line. So hypothetically, say this ball bounced 3 centimeter, but what the lady saw was like something like this. So this is still 3 centimeters. So it will be like 3 centimeters. We can do this, and we can figure out how long the line is. So for example, we say this is 3 centimeters and this is 3 centimeters, and that is the Pythagoras of the triangle. So if you lay out the triangle like this is A, this is B, this is C. So A squared plus B squared equals C squared. So we know this is 3 and this must be 3 because it's a square. It's a Pythagoras of the square. So A is 3 and B is 3. So 3 times 3 is 9. So it's 9. 9 plus 9 equals 18. And 18, you can find the square root of 18, and we know is 4. Yeah. So we know this line is around 4 because you can see from the calculations here it's around 4.2. But we'll say it's around 4. So this line must be around 4. So that is approximately the length. So while this is 3 centimeters, you saw this is 4. This is 8 centimeters. What she saw, the old lady, what the old lady saw was 4 centimeters. No, it was 8 centimeters. But you saw 3 centimeters. So how does this work? So this is basically the essence of time travel. So this is how basically time traveling works. But say it's an equal amount of time the train passes you. After 3 seconds, it bounces from the ground and up. So that's one rotation. So for 3 seconds. It's all for you and the old lady is both 3 seconds when this occurred, but the distance was not the same. So, for example, y is the length the old lady saw per second. So that is different from x per second, which is what you saw. So this is basically the essence. So what the old lady saw is different from what you saw. So the speed was different. And we know speed equals distance divided by time. So this is a distance and this is a time. And this is a distance and this is a time. And yeah. It's a really simple example, but if you want to take it a step further, you can do this, for example, with 2 glass mirrors, for example. So these are 2 glass mirrors, and this is like a beam of light. The beam of light will shoot. So the beam of light will be different to who observes it. And if we can take something to move at the speed of light, we can essentially time travel. But it requires even a huge machine to compact atoms. For example, these are atoms together to travel at light speed. So it will take a huge machine to transport humans, and not even say spaceships. But one person, one Russian guy, had the record of surviving in space for 183 days. And he time traveled for 0.02 seconds.